Very good. So we want to construct a confidence interval. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. The sample mean temperature is 162 degrees Fahrenheit with a sample standard deviation of 10 degrees Fahrenheit. Construct a 95% confidence interval for the population mean temperature of coffee sold. Assume that the temperatures are approximately normally distributed. So to build a confidence interval for population mean, we have two options. If sigma is given, we're going to follow these steps. If sigma is missing, we're going to follow these steps. If sigma is given to you, you're going to use Z. If sigma is missing, you're going to use T. So let us read the question carefully. You randomly selected 16 coffee shops and measure the temperature of coffee sold at each. The sample mean, X bar, is 162, and sample standard deviation, not the population standard deviation. The sample standard deviation is given to you as 10 degrees. So there is no way you want to use the guidelines for confidence interval for mean when sigma is known, because sigma is missing for you. So you need to follow these steps. Very good. Verify that sigma is not given. Of course, it's not given. We only see sample standard deviation, which is 10 degrees. The sample is random. Yes, we randomly selected 16 coffee shops. The population is normally distributed. Take a look at the last two lines. Assume the temperatures are approximately normally distributed. So we're good with the first step. We can jump into the second step. Find the sample statistics, N, X bar, and S. N is the sample size. Sample size is 16. We selected 16 coffee shops. X bar is the mean temperature of the sample, which is 162. S, or the sample standard deviation, is also given with a sample standard deviation of 10 degrees. Step 3, identify the degrees of freedom, the level of confidence, and the critical value, T sub C. Well, the degrees of freedom is N minus 1. Since N is 16, N minus 1 is going to be 15. C, or the level of confidence, is given to us as 95%. And T sub C, the critical value, is 2.131. Let me show you how to find that number. Let's use our calculator. Let me set up the calculator for you here and share the screen so you can see how to calculate the critical value. So first of all, to calculate T sub C, you're going to go to second, vars, and then you're going to select inverse T because you're trying to find the TC for T distribution. Very good. First of all, here you have 95% level of confidence. The area to the left, area to the right, 1 minus 95% is 5%. Divided by 2, you get 0.025. The degrees of freedom is 15 because it's N minus 1. 16 minus 1 is 15. Let us do the computation. Enter again. You get negative 2.131449. This number is the critical value on the left-hand side. To use the critical value, we have to use the positive number. Why? Because we want to build the distance. We want to calculate the distance. Distance cannot be negative. Distance is always positive. E is T sub C times S divided by square root of N. As you can see, T sub C is approximately 2.131, which is basically just written here. S, or sample standard deviation, is given to us as 10. N is 16. So on the denominator, we have the square root of 16. This distance is approximately 5 degrees. So everything must match the unit that you're working with. The average temperature is 162 degrees. Standard deviation is 10 degrees. and the distance is 5 degrees, approximately 5 degrees. Now we are moving on to calculate the confidence interval lower bound and upper bound. The left endpoint is x bar minus e, which is approximately 162 degrees minus 5.3 degrees, which is 156.7 degrees. And right endpoint is x bar plus e, 162 degrees plus 5.3 degrees, or 167.3 degrees. What is the interpretation? With 95% confidence, we can say that, hey, this population average temperature, or mu, is bounded between these two numbers, is always within these two numbers, 156.7 degrees and 167.3 degrees. How do you use your calculator to check to see if this algebra that you did is correct or not? To use your calculator, you're going to go to stat, you're going to go to tests and find Z interval. Click on Z interval. We don't have the actual data. If you click on data, you need to enter information from L1, L2, L3. We don't have information in L1, L2, L3. What else we have? We have the statistics of the data. Click on that. What is X bar? What is the average temperature? The average temperature of your sample is 162. What is S sub X? What is the sample standard deviation? 10 degrees. What is N? What is the sample size? It is 16 coffee shops. What is the confidence level? It says, hey, construct a 95% confidence interval. Don't forget to put decimals. Students usually tend to forget that. You need to add a decimal here. And then when you do the calculation, you see the T interval is 156.67 and 167.33 degrees, which is very close to what we calculated algebraically.